Hello, and welcome to the Data Practitioner Roundtable on Operationalizing Machine Learning. I'm Jordan Volz, Head of Field Engineering here at Continual, and I'm excited to discuss this topic today with our esteemed panel. We're very lucky today to be joined by Marcin Jimenez. He's the Director of Engineering at PricewaterhouseCoopers. Clay Stevens should be joining momentarily. He's a Senior Data Scientist at Wolters Kluwer, and we have Eric Kopfel, who's an AI Data Architect at Bloomberg. I'd like to thank everybody for taking the time to join the panel today and participate and to share all the knowledge that you've gathered over your years working with machine learning. Also note that everybody here who's participating is representing their own viewpoints and not necessarily the viewpoints of their employer. For anybody in the attendees, anybody watching this webinar, feel free to ask questions using the Q&A on Zoom. We'll review that at the end of the roundtable, and we'll try to get through all of them time permitting. All right, so let's jump in. I thought, first we could start with a quick round of introductions. So we'll go around. Can everybody just tell us a little bit about what you do at your company and also how you got started in machine learning? Let's start with Marcin.
Yes, hi everyone. Marcin Jimenez, Director here at PwC. We run a global platform for a lot of our teams to try to build and scale both data and AI assets. And around the question about how I got started was, I think I came from a place of necessity. I was originally a software engineer. I then moved into data science, and then I moved more into ML ops role as I really struggled to get into production with both data and AI assets. So pretty excited to talk more as to what I learned from my journey.
Awesome, thanks. Eric, let's go over to you for an intro.
Oh, sure. So my journey into machine learning is only about 10 years old. Before that, I had been kind of out west doing startups of all various sorts. And so about 10 years ago, I joined Bloomberg, and I was really interested in distributed systems at the time, which led to distributed analytics. And we started building out a legal analytics system, and that's where I actually ran into Jordan maybe about 5 or 6 years ago. And so we were kind of tangential to machine learning against legal documents. So I started picking up more and more on kind of the productionizing and the operational aspects. And so then when Bloomberg started really taking steps forward in forming a formal machine learning department, I was on board, and I kind of touch all parts of the data pipelines, and then I'm also working on some workflow and user experience initiatives as well.
Awesome. I like that you qualify that you've only been working in ML for 10 years, which is like, in reality, that probably puts you in like the top 5 or 10% of people in the field. But it's very humble of you, and I love it. All right, Clay, let's go over to you for a quick intro.
Hi. So my career path started in earth sciences, seismology, and remote sensing in those areas, a lot of GIS work. So that was where my computing experience comes from. And then as I started to work in engineering consulting firms, a lot of my job was, or the part of the job that I enjoyed the most, I should say, is bringing together all the different public available reports, as well as the internal private reports that we had, either through acquisitions or what have you, and also the data that we go out and collect in the field, and then bringing all that together into a consistent report, as well as automating the process of getting proposals out there to do additional work, just to make that as streamlined as possible. That part of the job is what I enjoyed most, and so I just kept leaning more heavily into that. And then machine learning came along. I started programming in Python and R before that. A lot of GIS is a lot of programming. And then the machine learning started to get into how you optimize, designs of roads, where materials come from. You just put all the data into a bin sort of and start doing random forests and things of that nature. But then as I pushed more and more into that, some of these companies aren't really ready for that kind of work. And so then I started looking elsewhere, and that's how I ended up at Wolters Kluwer, where they were doing a lot of very similar type of work, but it's where they bring in all the legacy products of the information that they manage. A lot of it's, I work in the governance, regulation, compliance division, and we bring all that information together to generate new products that are based on machine learning and artificial intelligence broadly, but a lot of NLP work is what we do. And I specifically work on the team that we try to take those models and put them into production. So.
That's awesome. So I think, everybody here has like a ton of experience building, maintaining, using machine learning systems. I think to start off, a great question to ask all of you would be just like, if you could summarize your experience over the past decade or two of working in this field, what's the hardest part of operationalizing machine learning? Marcin, let's go to you first.
Yeah, thanks, Jordan. That's a loaded question, because I think depending on who you speak to, everyone has their preferential way of operationalizing ML, right? It first started with which packages data scientists wanted to use, and then it kind of transitions into, okay, what's the best way to orchestrate it, right? From an orchestrative perspective, there's many opinionated ways of building and deploying your AI, right? And I think, thankfully, the community, the open source community, has done better about it. I think there's been a narrowed pick of them, right? But if you look across the enterprise and all the different flavors of ML, repositories, just how do you build ML? How do you scale it? The packages, how do you maintain it from a revision perspective? It's difficult, right? Because I think each and every team has their own way of accomplishing this, right? I mean, I think the argument is still out there to be said about, does a data scientist learn Python or R? And I think we have our own opinions, right? But it really leads to the challenge of how do you converge and standardize across all of this, right? Because if you have sprawl, I mean, it's tough to operationalize all of it. So that's a lot of my pain points today.
Yeah, the Python and R debate we're not going to cover here, but that's a good topic.
It's a loaded one too, right?
Clay, how about you? Same question. What's the most difficult part of operationalizing machine learning? Oh, sorry, Clay. I think you're muted.
Sorry about that. The most difficult part would be to getting the people on the cutting edge of the data science doing the POCs, proof of concepts, and doing the minimum viable products. Many times we have some very talented people that are really more qualified as statisticians than they are anything to do with software engineering. And sometimes they will put together a great model, does some great prediction, and that's it. They'll just zip it up into a pickle file and they'll say, there you go, my job's done, and they walk away. And so you're left with, what do you do with this? And getting everything. And then sometimes they don't even think about or work with the business people who are producing the data that we end up scoring. They got it, cleaned it, and sometimes their cleaning logic is separate from what they trained on. And you just have this big mess. And so what we've had to do is build a pipeline, and we have to get the production people, basically my team, involved with some of these far-flung data scientists that are better statisticians than they are anything to do with software engineering. And we have to interface with them right up front. As soon as they start doing a POC, we'll look over their shoulders saying, you might think about doing this, and go down a list of things that they really want to cover that will make, because we don't even know at that point if it's going to actually get to production, if businesses is going to actually fund it, and we're going to go that route, because a lot of times they're just dealing with proof of concepts, minimum viable products. And if there's not a lot of traction there, but with the executive leadership team, they may say, yeah, we're not going to bother with that, and they'll just let it go. And then why bother getting involved? But typically we want to interface right up front. And then if we do end up, they do fund it and we do go to production, it makes that job much more easier at that point. So.
Yeah, no, that makes sense. And it seems like that's a good strategy. Eric, same question. Hardest part of operationalizing machine learning?
I'm going to say probably talent, finding the talent. At the start of my career, like, you would only really have engineers. You might not even have a sysadmin. You might not even have a DBA. You would just have software engineers, and that's what it took. And then slowly things evolved, and you had some more niche roles. Now with machine learning pipelines, especially if you're talking about like online inference, you have specialists in Kubernetes, you have specialists in data, you have specialists in applying models, you have specialists in theorizing. It's probably takes, a good 10 to 15 different roles to kind of get some of these things off the ground. I suppose it depends like whether or not you're on premise or in the cloud. There are many shortcuts that you can take with some of the tooling these days, but finding those people, even in a city like New York, where we're based, can be incredibly difficult. And the amount of interviewing and combing through resumes that it takes to find people, and then to find the harmony as a working group to be able to, deliver is a whole nother phase of that. So I like to tip my hat to the underappreciated, like operational folks that, keep everything running while the data scientists get the glory.
Yeah, that's a good point. So I feel like both Clay and Eric hit on this, like this phenomenon that like to do ML, there's actually like a lot of different skills and personas you need. And I know, Marcin, this is something that you've had to deal with a lot in your job as well. So let's start with Marcin. My question is like, what kind of personas do you encounter at your company? How difficult is it to support personas who are doing much different things? And also like, what strategies do you have to try to like make that work well? And I think you're on mute, Marcin, sorry.
Yep, no, that's okay. Quickly figured that one out. It's an interesting time, right, for AI and ML, has been for the past couple of years, because I think to Clay's point around the folks that are building these models, right? I think he mentioned one persona could be the statistician now, and I think today you can consider business analysts and folks that are closely tied to the business. I mean, they're getting more involved with AI, right? And so it's like this the democratization, the spreading of AI, if you will. I can't speak today. That's happening. That it makes it interesting, right? And the area that we focus in on today is, where do we focus on those interfaces, right? Is it, high code, low code? Is it a UI experience that these folks are building and scaling UI from? And then there's also the cultural aspect I think Clay had also mentioned about is, where is that handoff point, right? Are these tools enforcing reproducibility and lineage? And so that somebody in production support can pick up the model and the experiment and the metadata and make sense of pushing it to production, right? And then are they also equipped with the tools to ensure that once you deploy it in production, can they monitor and make sure that there's nothing inherently bad or wrong going with the model? It's really tough to get a one size fits all for all the different personas, because every persona comes with a different perspective on the business problem.
Okay, Clay, how about your thoughts on this? And you're also muted, sorry.
I keep doing that. I tell myself I'm going to remember, then I don't do it. Yeah. The personas, I mean, as we probably all are aware, that it was just data scientists for a while. Then they're starting to separate into machine learning engineer and data engineer. And then there's different governance roles that we have. And so we've kind of settled down onto those where we have almost not even so much data scientists as just statisticians. Then we have some data scientists that know the NLP, know some other machine learning toolkits and things like that. They do some programming, maybe not as a software engineer would like to describe it, but they do know how to program and they do some of that. And then we go into the machine learning engineers and the data scientists start working together to get the scoring, the inference in place, whether it's real-time streaming or whether it's batch mode, or what the design of the database is going to be, how the data is coming from business to get fed into. Then we start dealing with the DBAs. Some of these are very legacy people. They know the databases in and out. And so we have to start interfacing with them. Sometimes we have to design schemas. We may actually, do we want to store stuff in the cloud in S3 or blob storage? And then, so we start architecting that whole system. And that's where the ML engineers and a lot of my team on the production side, we start interfacing with them a little bit before it goes to actually being funded and be turning into a product. And then once we actually secure funding, then we hit the ground running. We start running full speed and we start trying to get the pipeline set up from the data, the source of data within the company, or maybe even external clients coming in, goes through the model, and we actually scale things up and down. We typically use Kubernetes right now to be on demand based. We don't want to pay for compute if there's nothing to score, but when we have 1 million records come in just in one flash, we want to spin up enough containers so that we can meet that demand. And so getting all that stuff architected the right way, and so that we can serve our clients, whether it's internal or external, and then keep everybody happy, and then actually put the teams in place to continually monitor that, to make sure that anything, and have enough testing in place and all that, so that if we get a new model, we said, oh, we retrained it. And continuous learning is something that we're trying to push down towards our data scientists to say, if there's anything better, you need to keep continually learning, grabbing new data and seeing, are we getting any model drift, whether that's from data drift or the actual model is starting to change, or whatever their cause is, and actually retrain that, get a new model that actually gets that scoring up a little bit, but the confusion matrix, or whatever metric you're using to measure the model, and actually then pushing a new one out into production and streamlining that whole process. That's still a work in progress on some of our projects, some of our products that we have. It's really well done. It's streamlined, but then, and how to take the framework and just bolt it onto the next product that's coming along is still a work in progress. And you got to think that, it's not, you can't make it one size fits all, but we're trying to and there's still a learning that we're evolving as we go. So yeah.
Yeah. No, that's really interesting. And the process you described to me sounds very complicated, right? And there's a lot of moving components, there's a lot of moving parts, and it takes a large team to really make that successful, which, you guys have the resources to make that successful. I want to dig down a little bit more into this idea that does one size fit all or not? And going back to our discussion about personas, does it make sense that we try to give tools to every different persona that makes them successful within their own workflow, or kind of as Clay seems to be talking about, do we want to try to standardize on hey, we want to actually make it easy to get to production, so we want to have a more opinionated stack that makes getting value easy, but then maybe the users themselves have to make some sacrifices on their actual workflow. Eric, let's start with you, since we didn't ask you about the last question.
I like to start from a place of simplicity. So if there are very complex needs or really kind of confusing workflows, I try to just set them aside for a bit and kind of focus on a golden path, and really try to provide an experience for people that just does not have any issues, that kind of allows them to produce and gives them kind of a positive experience. So there's no missing data, or systems aren't timing out, or workers aren't dying and they're kind of lost trying to understand exactly what's going on inside this black box. I think if you focus on just, giving them a small piece of something that's really good, it's the positivity of them being able to quickly deliver something that's working, it kind of reverberates. And if down the line, someone comes to you and asks you for something more complex, again, I always kind of go back to things being semantic and simple, so that there aren't maybe complex UIs that people have to use, or workflows that they have to kind of step through or understand, or need a tutorial, that do really kind of clear declarative configurations that they can work on their own, and kind of digest it, get it to a point, and hopefully all of that we've kind of given them is anticipated because we've been using it ourselves for a while and kind of providing them a vanilla experience. You know, beyond the vanilla is the Bavarian cheesecake. They just don't know it. And you know, I think it's been a good strategy so far, but the field is also evolving so fast that every time you think you get like a model flavor or something down pat and like things are really cool and everyone's happy, like something is just over the horizon that's gonna like, you know, bring the pain again.
That's good insight. Marcin, let's go to you for the same question. I know you deal with like a ton of different tools in your job. What's your opinion here? Like, does it make sense to focus on like a production process that's like super opinionated, or should we focus on the kind of tooling that makes more sense like in the day-to-day context of the actual persona who's using it? Or is the answer like both? We need a compromise, or you know, I'd love to hear this.
Yeah, it's a fascinating question, and it probably differs from company to company and the type of use cases you solve for, right? I think, you know, just echoing some of the comments made by both Clay and Eric, right? I mean, there's clearly a talent shortage, and there's clearly a lot of different roles required as part of the MLOps process, right? And so I think of you know, when I think about scaling, you know, frameworks from project to project, I really look for a framework that, you know, enables the flow of information, right? Because it's really tough to find a DBA, a data engineer, a DevOps, MLOps, ML engineer, right? It's really find one role for each and every project. And what we end up having is some folks filling in on other roles, right? And so having a framework that enables the flow of information, right? Where, you know, a data scientist is building a model and they're enforcing reproducibility, right? That can enable, you know, QA and a ML ops folks to kind of tag in and look at, okay, this is how model performance is happening, all the way to production support. You know, production support may need to have more infrastructure related metrics, but they also need to have model metrics. That's really important to me, right? And if that's tied back into a user experience, it enables a user to be more self-service. You start to reduce the friction of needing, you know, that DBA or that data engineer or that ML engineer, right? As you kind of have that unified experience. So that's kind of the way we go about solving things. And I don't think it's, you know, foolproof by any means, but it seems to be a working strategy for us right now.
That's super interesting. All right, shifting gears a little bit, I wanted to go back into something that was kind of talked about a little bit. I think, Clay, you talked about this a little bit when we're talking about personas, that, you know, there's just such a wide spread of expertise needed for a lot of use cases. You need, like, you maybe have a statistician or a data scientist who knows NLP super well because you're doing like crazy cutting edge NLP work. And then to deploy it, you need to know about Kubernetes and system architecture and all, you know, how do you score 1 million rows in a minute or something, which I wouldn't expect a statistician to understand how to do that. So there's kind of like this disparity between like your DS and your DS skills and your machine learning skills, and then like what I would consider like software engineering skills or like system architecture, system operation skills. So like, is this a gap that you guys all see in your own day-to-day work? And like, if so, what are you guys doing about it? How do we begin fixing it? Is the answer like we need better tools, or like this is just something that exists and you have to like hire people who know what they're doing? And we've all said there's a talent shortage. So like, how is this something we fix? Let's start with Clay.
Yeah, so we've run into that exact problem that you just described, and there is a talent shortage, and there's just a big wide chasm between the software engineering side and the data science side. And what we've done is we have gotten some of the opinionated tools in place, and it solves not all the problems, but it solves some of the problems so data scientists can actually do a kind of lightweight deployment to what they call production. Elsewhere in our organization, they would not call that production, because production means SOC 2 compliant. It means all these other boxes are checked. And if a data scientist, the developer, just puts it into production, that it right away is not SOC 2 compliant, because you have to have this distinct separation between production and the developers that do it, and there's all this governance and process in place. And so we have products that go through that whole SOC 2 compliance type of production, let's say heavy production, and then we have the lightweight side, and it's mostly serving internal people. But we have some of these opinionated frameworks in place. They don't need to learn Kubernetes. It may be Kubernetes behind the scenes. They don't need to even learn Docker, even though there may be Docker, Kubernetes, Git, and all that is kind of managed for them. All they need to do is go into their either a notebook-like environment or VS Code or RStudio or whatever they want to use, and they just do their thing, and then they click a few buttons on a website, and it just kind of gets deployed into what they think of as production. And usually those type of jobs or works or products, you might say, are more for internally consuming business people, that they just want to say, show me some data science output, some machine learning model prediction, so that I can make a more informed decision as a business unit in the same company. And that's a lot easier because we're not worried about, getting audited or getting, fined if something goes wrong or losing a client. It's just internal. So we use both, I would say. We want, for the heavy production, we want the whole gamut of experts in place: the database engineers, the ML engineers, the system ops, the software engineers. That whole, we have to have them. We can't get out of it. And sometimes we do have to go to consultant firms to actually pull in that expertise when we actually need to get up and going. And then we can scale down a little bit once things are kind of riding smoothly. But so we actually employ both. But like you said before, we're a pretty big organization. We have the resources to be able to do that. So if you're a startup, I think you might have to go the opinionated framework route unless you have the experts in house. So,
right. No, that's a great point. Eric, I'd love to get your opinion on this. I know you've worked a lot of your career in software development, and you're now doing more of the machine learning thing. So, what has that kind of been like in terms of, like, you were kind of brought up ingrained with the software engineering best practices, and now you're trying to help data scientists machine learning. Do you see them struggling with things like versioning and using Git and, like maintaining artifacts and stuff like that? I'd love to hear your thoughts on this.
I do. It's like that whack-a-mole game sometimes you see at the carnival. Like, soon as you kind of attack one issue, or you kind of provide a solution for one issue. So say someone wants like interactive metrics, and so you put a lot of attention into that aspect, and then you get to like turn around, and all of a sudden, like, versioning or deterministic data is gone off the rails, and so then you have to go back that way. I think the cloud is, for all of its worth, has also kind of, for the very younger engineers, they no longer kind of learn the base toolkit that it takes to kind of just jump into a cluster and get dirty. So if something isn't running, how do you find logs? Like, even as simple as like, where are logs? Or like, if something is non-responsive, what are the steps that you're going to take to triage something that is hung? And so there's like all these little skills that I think people are kind of not learning. They are valuable, and I always kind of encourage the new graduates that we take on to kind of like go back to some basics and learn how to like kind of get dirty, I guess, as it is. I think in our overall culture at Bloomberg, we do take it kind of providing an internal developer experience very seriously. And this kind of goes back to when we were building a lot of native systems on Solaris and AIX and, very like non-standard systems, that there were a lot of tools that kind of allowed you to link and make the software. And that culture hasn't left. And so we are carrying that over into the machine learning world. It's just there are a lot more roles like we were talking about before, and the specialization is it's off the charts compared to what it used to be. I mean, even someone who's like working in NLP might not know how to do some other type of project. And so we are building the pieces for that. It's, you know, a relatively new field, a few years old. And so we don't necessarily have the full picture together yet, but we're really close and people are really happy with where we're at.
Yeah, that's it's a great point about kind of through the generations, a shift of what people learn, right? I feel like people coming out today, the big focus is on data, and a lot of like new people I see coming into tech. When I was getting started, I'm definitely getting older, but like when I was getting started close to 20 years ago at this point, I remember like I was someone who like understood how systems works, but I've never actually like built a server, right? Like I've never built a server with my bare hands. I remember like people who I was working with at that time who had been around for like 10 or 20 years, like, you guys don't even know how to build servers. You guys don't know anything. So now when I work with new people, I try to be like, oh, am I that guy now? Where I'm like, you guys don't even know like how the system works. Like you just know how to work with data. But yeah, and like obviously like, oh, well, if you're working with a system like that runs on hardware, like you have to know the hardware works. Yeah, it all kind of cascades, but the complexity I think becomes so difficult at sometimes that you have to like cut it off somewhere. So it'll be interesting to see like in 20 years, people will be like, ah, you guys don't even understand data anymore. All right, so we're getting kind of second half of this roundtable. I'm going to ask the last question for the panel, and then we're going to jump into some questions. We have a couple questions coming in from the Q&A. So last question is just, you know, and this is something I always love to ask people who work in data science and machine learning, because I feel like there's super insightful answers here. But you all have been working in the field now for, you know, like a decade or more. If you could go back in time and talk to yourself 10, 15 years ago, like what advice would you have to your past self to be successful and like to avoid all the pitfalls? So like, and you know, I think this is also like good advice for people who might watch the webinar, who are like starting their careers and thinking about these things. Like, what are the things they should know about and they should be thinking about that, you know, is maybe not talked about enough? So Marcin, let's start with you.
This is another loaded question, Jordan. You know, there's a ton I would probably give myself some advice for, but I think just where I am today, I think it's got to be the people strategy around this, right? Even outside of ML, supporting and building distributed scalable systems is tough. You add the ML, you know, component to it, and now you got a data lifecycle, you got a model lifecycle, you got artifact lifecycle, and you need to have folks supporting it at every step of the way, right? Dev, QA, you know, UAT, you know, production, it's post-production, right? There's tools and people involved in all of that. So I think that's probably, you know, if I had to tell myself anything, it's like think about the end-to-end flow and who's going to be upkeeping this and how do you make their lives easier to keep it running.
All right, that's great advice. Clay, let's go over to you.
Yeah, I think to reiterate on what Marcin said, at least what I heard, is the people skills are a lot more important than you think. This takes a team of people. It's very difficult. I think most people that I work with probably could, given how smart I know they are, that they could do this themselves, but there's just too much work to be done. And so you have to rely on other people and you have to be able to negotiate with them and work with them. And the teamwork, a lot of some of the things from extreme programming and agile, where you're pair programming and things like that, where you just get your together and you may be stepping into their domain, but they just want another set of eyes and they know that, you know, you're smart enough to figure stuff out. And sure enough, I can help them figure out. But then likewise, when I run into a problem going, why isn't this working? I can pull them in outside of their domain, but they just said, well, did you try this? Oh, why didn't I think of that? And then you fix the problem and you can move on. So having those people skills is critical, I think. And if I had to go back, I would say, don't just think you can figure all this out yourself. I think probably a lot of people on this call, a lot of people listening as well, like, oh, you may have experience from your academic work or what have you. You just figure it out yourself and you can solve the problems. If you just are these solo actor that think you're going to do that all the time, you're just going to have a massive headache and you're just going to really struggle in your career. I think learn to work with other people very closely. Yeah.
That's just great life advice. That's not even specific to machine learning. Yeah, but no, I agree. That's fantastic advice. It's actually, in my first job, that was one of the things, like in onboarding, they really hammered home. They're like, if you're stuck, raise your hand. We're paying you to do work. We're not paying you to like sit around and spin your wheels. So like raise your hand, get help. And I feel like a lot of people, especially like as you start your career, you're like, oh, I have to prove that I'm good, so I have to do it all myself. And I think it should be more about learning and working within the framework and stuff like that. All right, let's go over to Eric. Same question. What would you tell your past self if you could go back in time?
I definitely agree with what the other panelists said. You know, it's very great career advice. If I were to kind of maybe make it a little bit more technical, I would say to focus on user interfaces more. You know, now that kind of the browser and kind of the browser interface has become so central in the user experience, and it's like this common language from notebooks to dashboards to sysadmin to deployments, and you know, getting out your pods, and everything now is in the browser. That had I spent more time kind of learning some of the philosophical angles of user experience and visualization, I think it would have paid off. You know, a lot of times you expect someone to use some clunky CLI or script or something, and you don't understand the pushback. And it's like now 10 years later, like now you get it. So, you know, I wish I had a little bit more mojo in making the ease.
Yeah, focusing on ease of use, I think, is always critical. That's always something I keep coming back to in my career. That's great advice. All right, let's turn to some audience questions now. First question is for Clay, but I think if anybody else wants to answer, that's also fine. But Clay specifically, what are the main steps in the ML pipeline from your perspective?
Well, you could go all the way back to the proof of concept, minimum viable product stage, where a business unit person comes to you from a different business unit and says, we got this data and we want to make this prediction. First you need to do is there any signal there? And this is where the statisticians, data scientists have the first go round, and they start trying to go through the data and actually figure out, is there something that we can do with these data? Because it may not be anything. There may be no signal there. They may not be able to predict what the business person thinks they should be able to predict. It's just like, you don't have enough data there. Sorry, we just can't help you with that. And other times you can. And so that's the first step. Now, once you get something there where they say there's actually something there, then we have to start talking about, okay, now how do we get a continuous feed? You have to set up the data pipelines. You have to do that. And then you have to, maybe you need to store we have some legacy systems where we have to protect those systems. And so we have to basically siphon off the data that we need to do our scoring and not touch the other systems. And there's a whole process of doing that. And then you actually put the model into production, and then you actually generate the scores, and you somehow, usually via API or REST or something like that, where you send the data back to their systems, which are these old legacy systems in many cases, and they incorporate them in. And many times we have to interface with the other software engineers or database administrators on the other side and say, how do you want this? And they will work out a schema, and we send the data back. And so that's usually the process that we do. We kind of isolate our ML products from the existing legacy software products, is many of the times what we're actually doing. And then there's a process of continuous learning. Then we have to keep aggregating the data, because many times in a lot of the philosophy in the company that I work at least, there's always a human in the loop. We're just augmenting and assisting a human that makes a decision, allows them to make more decisions faster. and they realize how much they can rely on or not rely on. And sometimes when we first deploy stuff, it's great. They think the ML is awesome. And then suddenly over time, it starts drifting. And for whatever the reason is, maybe the clients are getting smarter and the data, oh, we can't get away with that anymore. And they find another way to get away with what they shouldn't be getting away with. And then our people have to start getting on top of them. And so it's a constant like cat and mouse game where you're constantly trying to, and so then we have to have the process of ingesting that data, getting the feedback from the humans at the other end. And then we have to go through the process of retraining. And then you need to set up that whole pipeline. It's just a continuous process. And to actually retrain the models on new data and then redeploy. And then there's a whole monitoring side, which we have consultants, some people internally that do that. And then we have some new positions that are coming up to do with what the risk is, evaluating the risk, how biased are some of our models. In some cases, that's really important to track, and who's actually evaluating that. So those are some new roles that we have. And these are from some people that are existing in the company, but that's another stage that we're actively starting to do, and governance on that side of things. So I hope that answered the question too, to some degree.
Yeah, I think so. I think we covered it. Marcin or Eric, you have any comments there before we tackle the next one?
No, I think that was spot on. I think, even before you embark on the technical journey, right, work with the business, understand the business problem. Is there the signal? Is once you do have the signal, is the model that you can create even tenable from a business perspective? And then incorporating those metrics into your post-production lifecycle, right? At some point, your model and your population may deviate. It doesn't make sense to maintain that model, or do you have to apply that continuous learning feedback loop? All of those are important questions you have to be comfortable answering, or it's not going to be a successful deployment.
Yeah, I think the working with business is critical, and it's something when I'm talking to newer data scientists, I always try to harp on that. I feel like data scientists kind of by nature tend to be like perfectionists, and there's something about looking at like whatever metric you're trying to optimize for, and like accuracy is like 92%. Like, can we get it to 95%? It's like, well, like, does that matter? Like, if you get it to 95, does that matter to the business, or is 92 good? Would they rather you solve another use case, or would they rather you spend like the next 4 weeks trying to get it to 95%? Those are good questions that I can't answer for you. You have to go talk to people. Like, what's the urgency of this use case? What's the urgency of the next use case? There's a limited, as we've all said, there's a talent shortage, right? So how much can you get done? Sometimes it's better to do more things and just get it as like a good enough state where the business is happy with the results, rather than like getting them like the best churn model that's ever existed or something. So yeah, very, very good point, Marcin. Trevor has asked a couple of questions here. They're kind of lengthy. I'm going to try to summarize them. I apologize to Trevor if I don't summarize them well. But I think the first question is that there's a lot of new innovation happening all the time in AI and ML. So like, what's the best way to integrate like new tools that pop up into your existing processes? Do you guys have like, is there an evaluation process? Like, once you like things, how do you put those into the system? This is probably something, Marcin, I know you like spend a lot of your time looking at tools, so this might be a good one for you to chime in on.
Yeah, I'll answer, and I'll give Clay and Eric a chance to answer as well too. I think this comes from like our work process perspective. I think it's really important as an ML shop, as a platform shop, right, to get ahead of the cutting edge technologies. And so we work in program increments, and they can span anywhere from 8 to 10 weeks. But one of the things that we always challenge our team to do is, reserve some time for the innovation, for the research and design, for really understanding what's coming out there, right? I mean, we see new algorithms, we see new infrastructure, new open source projects, right? They come out all the time. It's really important to get a pulse on what's out there and what's coming, because at some point you'll have a request from the business, and your stack may not solve that that request, and it's always good to know what's out there so you can you could apply that solution for your platform.
Claire, Eric, any thoughts on that?
I would just reiterate the same thing that Marcin said. We tend to try to, like, let's say when the BERT and the transformer models came out, that's something that recently had. We do a lot of NLP, so we need to make sure that we were on top of that, being able to use, whether it's BERT or Tiny BERT or the different Hugging Face models or whatever is out there. We want to make sure, because we don't want to just rely on some, other deep learning algorithm that is already outdated, that was cutting edge just 5 years ago. And now it would almost be an embarrassment to say that you're still doing those kind of models for NLP work. So you want to make sure that you're on top of it, but also you're just providing a much better quality product to your consumers. So you want to make sure that you're on top of things. Yeah.
Yeah, your comment there actually, I'm going to ask another question because your comment there reminded me of a question I wanted to ask, which I think is kind of a hot take, but I have a good friend who works in the space, and his view is that like in 10 years, no one will ever like train a model from scratch again. And his argument is that AutoML is getting better and better. And like at some point in time, like software engineers will have solved the AutoML problem for like low hanging fruit type use cases where it's like, hey, you want to do like sales forecasting or whatever, like plug in your data, you know, this is optimized. It does a ton of hyperparameter tuning. It figures out what's best. And like, you don't really need to tune it that much. And then for hard use cases, it's going to come down to like transfer learning. Like, hey, you're never going to build a better like vision model or a better NLP model than like Google or Facebook or whoever. And like, they're probably going to open source it and like charge you or like, you know, they'll commercialize the asset. So I think there's like this view that like, hey, in the future, you may not actually do that much like manual training anymore. Like it may just be a ton of transfer learning on hard stuff because like you're not going to pay the compute to build these gigantic models. And then like AutoML gets good enough that like they can solve most low-hanging fruit type problems. Is this a valid viewpoint? Do you guys agree or disagree? What's you know, if anybody wants to tackle it?
Yeah, I'll start. I think never is a strong word, but I think we can definitely get there. You know, it's really computationally expensive to train some of these models, and so the way I view it is if I can use a pre-trained model and save on computational infrastructure and time and money spent, I mean, why not? And so that's you know, appealing. I caution at never training again because there's always that niche use case, right? I mean, we're seeing the evolution of Web3, right? And I just think the problem space is continuing to grow, and I'm not certain that we can generalize enough models that cover it all.
Yeah, good point.
Play, Eric.
I would add that some of the AutoML right now is when you click on it, what you realize what's happening is they're training a deep learning, they're training a random forest, they're training a SVM, they're doing all these things, and you're just trying to figure it and then just picking the best one. That's a lot of compute that just to get all of those models trained. And then if you're doing grid searches or some hyperparameter search space to optimize each one, I'm not sure if you want to spend that up front. If you talk to just a talented data scientist, they'll look at the problem space and pick intelligently what the best model is, and they'll make a pretty good educated guess, and they'll end up with a good result. And then you're avoiding spending all that compute, because we've had a few cases where we've opened things up to a lot of the business users, and they just click a few buttons, dump their data in, and click a button, and then 3 days later, after they've had 20 virtual machines spun up in the cloud, all training these models to pick, it's like that's tens of thousands of dollars that you just spent to someone to go, oh yeah, that didn't really work, and they just dump it and go on to the next thing. I don't know if we're fully there yet. If you have on-prem, yeah, go ahead.
No, I was trying to say odds are they don't see the bill or the price tag associated with that click of the button either.
No, they don't. Yeah.
It's good to have some short circuit mechanism in there as well. All right, so Trevor's other question, it was going back to our talk about like the software engineering people who are actually implementing and maintaining the systems. Does this get us into a CI/CD type situation of being able to train and update models and then let other frameworks like CI/CD, I suppose, take over and deploy? So I think that's kind of like, does all this point to like, hey, like we should be adopting more of these types of paradigms in our work? I mean, like, are you guys in your actual ML pipelines? Do you like go as far? Do you have like CI/CD systems set up that are controlling various aspects of the system? I think Marcin, you might be going to talk about this based on things.
Yeah, yeah, we heavily use CI/CD, but I think there's some differences to kind of note, right? Because With our CI/CD, right, we tie it back to code, we build artifacts, we deploy those artifacts, but the artifacts differ, right? There's data, there's model, there's just your code, right, that executes the inferences. And so it's pretty linear for a software engineer to understand, okay, I have code and I want to promote it through my production environment, distribute my continuous learning code. But where it starts to differ is data, right, and the models itself. For us, right, we ship a lot of pre-trained models and they can be used and they're consistently used across the environment, but the data is always different. There's governance on data, who can access what data, what environment can see and access that data. And so as soon as you mix up the data and you use it on different models, you now have sprawl of, unique models for different projects, and they all have, different performance, right? So that's where the CI/CD starts to finish, and that's where you start to go into model governance, model monitoring. How do you enforce, accuracy and with your target population? That was the extent of CI/CD for us, and more into model ops start to take over.
Yeah. I've always thought that like CI/CD is a very good paradigm to base your like ML workflow off of, but it in of itself is not like 100% the solution. You need like kind of additional frameworks that like understand the ML workflow a little bit. Okay, so how much time we got left? 5 minutes. Okay. We have another question here. Beyond compute, how do approaches like AutoML, et cetera, interact with explainability, ethics, governance, so on and so forth?
Depends on what AutoML you end up going with. If you go with something like a random forest, those are the kind of called classical machine learning, whether it's support vector machines or random forest or a boosted, some algorithm that you get the features and you know what the feature importance is, you can get explainability that way. Deep learning, as far as I'm aware of, there's a lot of research going on in this area, but they're not very explainable. They perform great, you get great performance out of them, but they won't tell you why they made a certain decision. So that's still, you're just going to have to make the decision. Do we want the really good performance but not being able to explain it? Or if you need the explainability, maybe you need to drop down to a classical machine learning algorithm, not deep learning. Yeah, that's my take.
All right, I'm going to ask one last question. The AutoML stuff kind of has me thinking about this, and I think like kind of in the context of like this whole, how do we operationalize ML, building good systems, many people mention declarative approaches in this. So I assume like some of you guys behind the scenes are doing some declarative stuff, which I think is pretty exciting. So like, let me posit a question for you. Like if you could build a system where like expert users could come in and build pipelines that other users declaratively leveraged. So it's not actually AutoML, right? Because like you have an expert designing the use case, and then like other people would just come in and say like, hey, here's my file that leverages Clay's awesome NLP thing that he built. Like to the end user, it's AutoML, right? Because like they're not making those choices, but it's been set up by a user. How does that look, or how does that sound? Does that sound like an interesting future for AI possibly? Eric, you look deep in thought, so I'm gonna ask you.
I was just envisioning AI like on Spring or something like that when you were saying that. Because I think, some of this is inevitable. You can't always start from scratch, and you can't always go back to like the bare basics. And you see this in all kinds of software systems that have been built up over the years. And I think it's kind of inevitable that the same will happen with machine learning. What that looks like, I'm not quite sure, but I can imagine that someday in the not so distant future that someone will be able to not just to do applied machine learning, but like chain these things together in kind of a pipeline, if you will. And I mean, really, what would be the downside of that? You know, what would be the impedance to that actually taking shape?
Yeah, that's a good question. Is there a downside? I mean, I've always thought, I feel like the term citizen data scientist is very loaded. And I've always disagreed with the thought that like you can just take a random person and make them a data scientist. But I like the idea that data workers can go in and leverage like excellent machine learning work that your advanced people have done. That's always been a great appeal to me, that I don't think, I mean, it's kind of like the idea of like, hey, if we could all drive cars, that would be great, right? If you have to be a professional driver to drive a car, like, yeah, well, you know, this automobile industry is going to take off. And I think like apply similar logic to ML. Like there's a lot of excellent people working in data who understand your company and their like data and use cases well. And that I think is perhaps the direction that the field needs to go in to really make operationalizing ML super easy. We are out of time though, so I'm going to thank everybody on the panel a ton for participating. I think we had a great discussion. We had a lot of great insights. I think we had a lot of great questions from the audience as well. So thanks a lot for kicking this off. And I know you're all super busy and you got to run. So I will hopefully talk to you guys soon.
Awesome.
Thanks
Thanks for
Jordan.
having us.
Thanks.
Thank you.